So this video is just an alternate way to do the examples we saw previously. If you would prefer not to watch it, if you feel like the other problems made sense, don't worry about it. You don't have to necessarily take notes on this. But if you feel like the last way seemed a little bit clunky, there's a slightly smoother way you can solve it. You still have to do quite a bit of work, but it is a little bit smoother. So in example 1 in the previous video, we were looking at 3x minus 37 over x plus 1 times x minus 4. So we still have to get to the point where we have this equation written out. Let me go ahead and change the coloring now. Okay. So we have this equation, a times x minus 4 plus b times x plus 1 equals 3x minus 37. Now instead of distributing, I know this equation has to be true for all x. Otherwise it wouldn't make any sense. This has to be true for every single x. So what I'm going to do is pick some strategic x values. I'm going to pick the zeros of each of these factors, and I'll show you why in just a moment. So I'm going to pick x equals 4 and x equals 1. So let's start off with x equals 4 and see what happens. So I'm going to end up with a times 4 minus 4, which is 0, plus b times 4 plus 1 equals, I also have to put x equals 4 over here. And now what's nice is this is all just going to equal 0, so the a goes away, and I'm left with just an equation in one variable. 4 plus 1 is 5, so I have 5 times b equals, now I do have to do the work on the other side, 12 minus 37, and so then I can just immediately solve for b. So what's nice about this is it makes one of your unknowns go away, right? The a just disappears because it's just 0, and so I get b equals negative 5. And then let's do the same for x equals negative 1. So I'll have a, and then I'll have negative 1 minus 4, plus b times negative 1 plus 1. Again, this is just going to be 0, which is nice. 3 times negative 1 minus 37. So I end up with negative 5a equals negative 40, and so a equals 8. So you notice I still get the same answers, and then you can go from here and write down your final answer. I think this looks a little bit cleaner and sort of makes sense, but in the end you're still doing a similar amount of work. For the next problem, we ended up with an equation that looked like this, a, and then we had x plus 4 plus b times 2x minus 1. And so we're going to use, first of all, x equals negative 4, so that would be the 0 here. So the a term's just going to go away. You don't even have to write it, but I'll keep doing that just so we see what that looks like. And then I have b 2 times negative 4 minus 1. So I have b times negative 8 minus 1 is negative 9. 9 plus 9 times 4 is 36, so we get 45. And so then b ends up equaling negative 5, which is what we got before. Now for a, it's a little bit annoying here because we'd have to use 1/2. So this might not be the best way to do it from here. So let's go ahead and plug that in. Sorry, I lost my train of thought because I was thinking there's technically another way you could do it. You could actually, at this point, think about your equations. A plus 2b has to equal negative 9, right, for the x's, and then you could just use negative 5 in there and solve for a. So you could combine this strategy with the other one is what I was just thinking about. But anyways, let's continue with this and see how the fractions will end up. So this will be 0, and then this equals 9 minus 9 times 1/2. So this will be a times, actually I really don't even have to use fractions. If you'd rather think about this as decimals, that's fine. 9 minus half of 9 is 4.5. And so this works out really nicely actually. And so we end up with a equals 1, which is also what we saw previously. So once again, this is still going to take some work. You still have to do the first step where, let's go back to this first example. The first step is where you say, well, I know this has to be a over x plus 1 plus b over x minus 4. You still have to add them. A times x minus 4 plus b times x plus 1. But sometimes this strategy just makes a little bit more sense. If you don't want to have to worry about a system of equations, you can just do it using this strategy. So once we had that, we picked the zeros, plugged that in for x, and then we could solve for a or b, depending on which one we were looking at the time. But either way, that is partial fraction decomposition. You've now seen everything for that.